a statement that as per Wegener, these rocks must have formed. As per Wegener, these rocks must have formed when Gondwana land existed in the past. When Gondwana land existed right. So that is all about the second evidence, that is the evidence of delight. Right. Then what do we have? Third evidence is mountain similarities. We can understand mountain similarities. And here three mountains are there. One in the Europe. In Europe, you have a Scandinavian mountains. Okay. Scandinavian mountains in Europe. Then you have Greenland mountains in Greenland. East Greenland mountains. East Greenland mountains in Greenland. And you have Appalachian mountains in North America. Appalachian mountains in North America, right? So we have how many mountains? Scandinavian mountains, East Greenland mountains, and Appalachian mountains. Appalachian mountains is where? In this is North America. East Greenland mountain is in Greenland, and Scandinavian mountains is in Europe. So currently, if you look at all these mountains, they are separated very, very far away from each other. Between all these, what do we have? Atlantic Ocean is there, right? But when scientists, geologists, they look at three things in the mountain: rocks of this mountain, the structure of this mountain, were measured. The type of rocks, first of all, what kind of rocks are there in the mountain? Second is the structure, and third is the age. So in all these three parameters, what they found out? They are exactly similar. Okay, all these three mountains have same rocks, same structure, and same age. But these mountains are what? Very, very far away from each other. So how can you explain this? The only explanation is that initially all these were what? A single mountain. But due to continental drift, what happened? You have the Laurasia. Laurasia split apart into Europe, Greenland, North America. So what happened? The same mountain, basically single mountain was there, mountain chain was there. It broke apart into three different parts. So no matter how many parts it break apart into, the rocks, structure, age will remain what? Same. So that is why if the mountains are similar but they are so far away from each other, then only possible explanation of that is that all these three mountains actually are part of a single mountain chain. Okay, so what conclusion you can draw from these? That all the three mountains are part of single mountain chain. The three mountains that we have studied here are part of single mountain chain that broke apart due to continental drift. So this is last line you can write. The three mountains are part of single mountain chain that broke apart due to continental drift. That broke apart due to continental drift. right? Then this is third one or fourth one? Evidence, fourth evidence, right? So then we have the next evidence. Next evidence, what we see is in terms of the what we can call as the placer deposits. The term that we can write as next evidence is placer deposits. Right? What is placer deposits? Basically, placer deposit is a kind of related to minerals. Generally, what happens? Suppose somewhere, what do we have? We have mines are there. Okay, so mines are present where? From the surface going all the way to the interior of the earth, and as you keep on digging, you'll find more and more minerals. So what happens? Suppose that this is the area where you have a lot of minerals are there, and if a river is flowing over this area, let us say, so what will this river do? This river will cause erosion, and it will take some minerals from here and will take it away from this area, and where you will find then these minerals here gradually it will find somewhere closer to the river, around the river, far away from the source of the mines. Clear? So these minerals that are discovered far away from their source, brought by what? Brought by rivers. Such minerals are what we term as placer deposits. Okay, so you can write the definition. Understood what is placer deposits? Basically, from the area where you have a lot of minerals, river is flowing over that area and bringing some of the minerals along with itself and depositing it nearby its bank in the out further apart. So you can write what is placer deposit. It is a deposits of mineral at the surface. It is the deposit of minerals at the surface, brought by river water, brought by river water from the source of minerals, brought by river water from the source of minerals. Right? So that is the placer deposits. Now what we see in the case of two major minerals, one is diamond, other is gold. In terms of diamond and gold, if you look at the placer deposits of these minerals, placer deposits are found where? In the Africa. While if you look at the source region, the main source of these minerals that extend all the way to below the ground surface, they are found where? They are found in South America. Okay, so in the context of diamond and gold mines, where are placer deposits of those mines? In the Africa. Where are the source region? They are in South America. But what we can see on the map today, South America and Africa, they are closer or away from each other, far away from each other. So there is no way that from there placer deposits can develop there. Okay. Are there any other examples of natural mines? Places where the depth is too much. A lot of mines are there. India also have diamond mines in Panna, in Madhya Pradesh. Okay, so basically all mines. Now, what do you mean natural mines? Like human, do they have mines? Human-made mines? What is? But we mine from minerals. So mining mines means like I'm not talking mine. Mines means they're already existence. You start to dig inside those mines, then you get minerals, right? So placer deposits. When can placer deposit develop? If we have source region here, rivers are flowing over source region and depositing the sediments here. That can happen only when this entire region is connected or is a part of single landmass. So we have source where? In South America, placer deposits where? In Africa. So how it is possible? It is only possible if how both these land masses at some point of time were part of the same landmass. So from this also what we can understand, okay, that the discovery of these diamond and gold mines, either the source region or the placer deposits, what they explain that at some point of time, South America and Africa, they were part of same landmass or joined together. Okay, both South America and Africa, it can be below the surface as well. Okay, extending from surface to, because surface is where erosion is happening, but does not mean that mines are concentrated, minerals are concentrated only there. It can go even deeper inside the surface. That is why in South America it is largely, mostly very deep inside the surface. That is why South America is not so much popular for extraction of diamond and gold, because where it is easier to extract them when they are closer to the surface. So diamond and gold, which continent is famous? Africa is famous because it is found very closer to the surface, easier to extract them, easier to mine, right? Even when you're walking near the river banks, it is possible that you might find some rocks in which you will have the presence of diamond or gold, right? So yeah, that is the fifth evidence, that is placer deposits, right? Fourth evidence, so placer deposits. Then what do we have? Next is next we have is what we can say, the behavior of an animal, which are called as lemmings. Lemmings behavior. Lemmings behavior. Lemmings are basically a kind of belong to rodent category. Rodent means same category in which you have rats and this what else you have, moles and all these are there, but much more bigger in size. Almost we can say like slightly bigger than the size of a rabbit. Okay, that is how lemmings look like, but belong to the rodent categories. Okay, so these are the rodent, and they are found where in the Scandinavian region. The lemmings are found in a Scandinavian region, Scandinavian peninsula of where Europe. Understand Scandinavian countries like Sweden, Norway. These countries are what we call as Scandinavian countries. So lemmings are found there. Now they show a very strange behavior. What do we call this behavior? Biologists term this as mass suicide behavior. Okay, lemmings take part in what is called as mass suicide behavior. Mass suicide behavior. What is this mass suicide behavior? Basically, whenever the population of lemming increases, okay, whenever lemming population increases, if population is increasing, food resources are limited, that means what will happen? Lemmings will have difficulty in finding food. So whenever there is sudden increase in population of lemmings, what they do, they start running toward west. Suppose this is your Scandinavia. So they are residing in the Scandinavian region. So they start running toward west in huge numbers, in thousands and thousands of number. Lemmings start to run in a large group toward which area? Toward the western area. And what do we have on the west of Scandinavia? We have Atlantic Ocean. So basically, they jump from the mountains, cliffs are there. They jump from there and then they drown in the Atlantic Ocean because they cannot swim, and also water is very cold. Okay, so this is strange behavior flaming, where they are doing what seem to be doing mass suicide by running toward west, is the behavior that was observed, and later on it was explained by continental drift theory as well. Why? Because scientists then explained that lemmings have this genetic predisposition, as they termed it. Lemmings have genetic predisposition. What is this genetic predisposition? This behavior that they exhibit when they start running toward west. So why they are running toward west? Because earlier when you have a Laurasia, at that time what is happening? There is no ocean here. Scandinavia is connected with what? Another landmass, that is North America. So that time when they run toward west, what they used to find? New land, new areas, new food resources. So this information has been continuously, what we can say, transferred from one generation to other generation, and this is something that is what they are exhibiting even today. Okay, lemmings are almost what we can say. It is believed that not even Laurasia, even before that. Okay, Laurasian, like you have last only 300 million years of history has been told by the Wagner, or the age of Earth is how much? 4,500 years. So this kind of movement has been going on for many cycles. That means this is one cycle. Pangea broke apart into different land masses. Again, what will happen? All these will join together. So this kind of breaking and joining has happened at least 5 more times in the past. Okay, so that is not in our syllabus, but if you want to read about them, I have uploaded video on YouTube. Okay, about all the cycles since 4,500 million years ago. What are the names of the supercontinents? Rodinia is there, and then different continents are there. How it has broken apart and everything like that. So this is out of syllabus, but if you are interested, you can look at that video. 10-minute, 15-minute video is there. You will able to understand that. Right. So lemmings are obviously they have been surviving for a very long period of time. However, this genetic information has not passed in lemmings that today we do not have any land mass here. What has happened? Land mass has broken apart, and now in the place of land mass, the area is filled up with Atlantic Ocean water. So they do not know this, and that is why they simply run as per their genetic traits, and that is why they are dying in mass in the Atlantic Ocean. So that is also how we can explain or provide this behavior of lemming as an example of continental drift. So that is the fifth evidence. The last evidence is what you can write fossil evidences. The sixth and the last evidence that we can give is fossil evidence. What is fossil? What? Basically, fossils are what? Dead remains are there. Okay, either it can be of plant or animal, both. Right. So what happens when the animals or plants they die? Gradually, what happens? They will be lying somewhere. So gradually, as sediments move over their bodies, gradually this sediment will undergo huge pressure changes. Due to this, sediments will can change into rocks, and these animal remains will then get what? Trapped within the layers of this rock. Largely, it is sedimentary rock. So these trapped layers of dead remains of plants and animals within a rock layer is what we can call as fossil. Okay, so in bracket you can write the definition. It is dead remains of plants or animals. What is fossil? Dead remains of plants and animal preserved within sedimentary rock layer. Dead remains of plants or animals preserved within sedimentary rock layer. Right? That is the fossil evidences. So some name of the fossils you can write down, which you have to remember. Fossils of old reptiles have been found distributed in different part of the world. Like Mejosaurus is there. Then we have Lystrosaurus, Mejosaurus, Lystrosaurus. We have Glossopteris. These are some of the notable fossil evidences of old animals. Okay, these do not exist today. These are the animals that used to exist during the Jurassic period, for example, right? So they were that time. What is happening? A lot of continents are joined together. So Africa is joined with South America, and these animals are running over the entire continent land masses. But due to continental drift, what happened? Some population will remain in Africa, some population will go with South America, and when they died, their fossil basically got preserved in different land masses, right? So, for example, if same species of Mesosaurus you're finding in South America, same you're finding in Africa, how can you justify that? Because they could not have swam from one place to another place and like that. They must have moving over these areas when the land masses were joined together. Okay, so the fossil evidences of Mesosaurus. No, same species cannot exist because temperature, climate conditions will vary. Okay, because even if you look at elephant, we have African elephant, we have Indian elephant, both are elephant, but are they exactly same, identical? No, there are a lot of variations in morphological characteristic, in height, in the shape of head, in the shape of your ears, tooth, and all these things. Okay, lions are there, African lion, Asiatic lion, you'll see the differences. So it is not possible that exact same replica of this species. A bone structure is same, no, but no, size and everything will differ. Okay, because if you have rainy climate, high temperature, their size will differ as compared to your polar climate and all this. So bone characteristics is basically determined by the sizes of this fossil. Also head structure is there, that is also changed, right? So Mejosaurus, Listosaurus, Glossopteris, and recently one frog species has been discovered from Madagascar as well as in Western Ghats. That is called as Nasica batrachus. This is the species of frog. This is in 2012. It was discovered for the first time. Before, it was believed that this frog species only exists in Western Ghat. But now we have evidences that this frog species, same species, you will find in Madagascar as well as the Western Ghats. What does it explain? That Western Ghat and Madagascar must be joined together at certain point in time, as said by given by the continental drift theory. Batrachus, Batrachus. So total how many evidences we have discussed? 6 evidences. These are the major evidences that are provided in support of continental drift theory of the Wegener. So Wegener gave the evidences. So when he presented his theory again in 1918, okay, with the evidences, that time also again scientists asked that even if we believe that this kind of movement has happened on the basis of evidences, there must be what? Some kind of forces, huge forces, big forces that is acting, that is causing the splitting of the continental land masses, and also they are causing the movement of these land masses in different directions. What is the force? So then Wegener explained the forces. What forces are responsible for the continental drift? Forces responsible for continental drift. Forces responsible for continental drift. So Wegener said two forces we can understand which have caused or which has caused the continental drift. First, he called it as pole fleeing force. Pole fleeing force. This force acts due to Earth's rotation. Okay, the pole fleeing force, because Earth is what? Rotating on its axis. So if anything is present on the Earth, due to its rotation, what will happen? Certain amount of forces will act on the on the land masses that are present on the Earth, right? So that is what is the first force, pole fleeing force. And second force he called as a tidal force. Second force that Wegener said is responsible for drift is what? Tidal force. What is tidal force? This is the force said is acting. Why? Because of gravitational pull or gravitational attraction of sun and moon. The tidal force are the gravitational force acting due to presence of sun and moon around the earth. So these two forces when joined together, that is what Wegener tried to explain is responsible for continental drift. Because see what is happening, continents are there on the earth and what is happening? Moon is moving around the earth, revolving around the earth. Suppose moon is moving like this from there to there, so what it is doing, it is pulling the continental land masses and dragging it along the direction of its motion. So if it is happening over millions and millions of years, even a small displacement is happening due to the revolution of moon, what will happen over a long period of time? We can see a large scale displacement of the continental landmass, right? That is why this theory was discarded, because when Wegener said about this theory, first they said that the rotation of or revolution of moon is happening in single direction, right? So that is why what we are seeing, continents are moving in different direction. And second, if you combine even both these forces together, it is very small in magnitude, and such a small magnitude force cannot cause such huge large scale splitting and the displacement of content. So this is the biggest criticism of the Wegener. Scientific community said that the forces that Wegener has given, which can be responsible for content drift, is not sufficient. So this is not sufficient in magnitude. Not sufficient in magnitude. Clear? So that is the criticism. What is criticism? Criticism of Wegener's theory. If you have to write, what you can write, that the forces that were given by Wegener was not sufficient enough or adequate enough that can cause the content drift, splitting, and the movement of the content. And second point, as you said, that if the tidal force is the major force, the movement of the content should have happened in the same direction, not in different directions. So that is what Wegener was not able to explain correctly, that why it is happening, how it is happening. So overall, whatever he has said that time, because in 1913, 1915, people discarded theory. It is only later in 1950s, 1960s again, when other scientists started to work in the same field, people's interest in the Wegener's content theory arose again. And today we accept that, okay, that yes, what Wegener has said, if you remove the forces, what he has given, everything else what he has said is kind of correct. Okay, so what was the only missing factor in Wegener's theory? He was not able to explain what forces are responsible for the drifting of the content or splitting of the content. And thus, few years later, okay, another scientist, Austrian scientist, who studied in US by the name of Arthur Holmes, he was very much influenced by Wegener's theory and he considered it to be correct. And thus, he wanted to explain that what are the forces responsible for continental drift. And thus, to explain these forces that Wegener failed, he gave another theory which we have to study, which is called as convection current theory. Somewhere in 1940s, early 1940s, another which is geologist, Arthur Holmes, gave a theory that is called as convection current theory. Why he gave this theory? To explain the forces that is responsible for continental drift. So he said that continental drift is not happening due to forces that is coming from outside the Earth's surface. The only way how we can explain this drifting and splitting is because this forces is coming from where? From below the Earth's surface. And that is when, on the basis of the calculation, everything he made, that what is the crust made up of? Sial. Below Sial, what do we have? Sima. And temperature increases, so we have Sial layer, we have Sima layer, and then we have Nephe layer, for example. Okay. So he said that what happens, because yesterday we have discussed about the structure of Earth. That means when the Arthur Holmes was giving his theory, that is, that time Sial, Sima and Nife was replaced by what terms? The new terms. That was crust, mantle and core. Okay, so Wegener was using the term Sial, Sima, Nife, but Arthur Holmes in his theory, what he has used term? New term, that is crust, mantle and core. So what Holmes said, that what is happening, we have discussed about the temperature. As you go below, what happens? Temperature keep on increasing. So as the temperature increases, here rocks cannot be found in the solid state. They will become molten in nature, and also a lot of gases are there in these areas. So due to this molten nature, what happens? These molten rocks start to rise in the upward direction, because if they become molten, that means their temperature is higher, density is lower, that means they become lighter. So they start to rise in the upward direction. Okay, these molten rocks start to rise in the upward direction. So what is happening due to this? They are very high temperature rocks, molten in nature. So if they reach near the crust layer, what they'll do? They'll start to melt the rocks of the crust because of their high temperature. And thus, over a long period of time, the place where they are directly striking the crust from below, their melting of the rocks will happen. Due to this melting, what will happen? Initially, we have a single crust. Now this crust will break apart into two parts. One part of this side, one part will be this side, because the central part has totally molten. Okay, a kind of gap has been created. That's what is happening. We have this, we can say as this is crust A, this is crust B. Clear? So this movement of this molten rock, he termed it as what? Convection current. Yesterday we have discussed in sun, what is convection? It is vertical movement of fluid. So what is happening here? Vertical movement of fluid is happening here. So convection moving in a strong current like fashion. So that is what he termed as a convection current. That means what Wegener is trying to say. In the continental drift theory of Wegener, what he has said, what happens first? You have a single crust is there, single landmass is there, content is there. That first of all, what happens to this content? It splits apart in two parts. So Arthur Holmes said, why splitting is happening? Because of this strong convection current that is rising from the lower part of the earth. Clear? Example, Gondwana and this Pangea. Why it is split apart in two parts? That means in the entire Pangea region, you have the convectional current that is rising, melting the rocks in the central part, and thus cause the Pangea to break apart into two different land masses. And same thing has happened at local scales on different continents. Now, second part of Wegener theory was what? That not only the land masses are splitting, they are also moving in different directions. So movement, he said, is what happens. Why happens? Because see, the volume of convection current is very huge. So after they reach here, they start to melt the crust. But at the same time, what the convection current will do? They will start flowing below this crust. Okay, you have like kind of like this is there. The convection current is moving like this. And after that, what will happen? They'll start flowing horizontally in both sides. So one part of convection current will move like this, one part will move like this. And due to this, now what is happening? This is crust A, this is crust B. Below both of this crust, what is happening? Convection current are flowing in different directions. So due to this, what will happen? This crust will start moving in this direction. This crust will start moving in this direction. So the movement of the continental land masses, why do they happen? This is what we can call as HCC. That is horizontal convection current. This is what we can call as VCC. That is vertical convection current. Okay, so for simple simplification purposes, we termed this as a horizontal convection current, this as a vertical convection current. Clear? So splitting is happening. Why? Because of the vertical movement of the convection current. Why the land masses are moving? Because of the flow of horizontal convection current. That means it's the same like if boat is there. How boat can move over river? Two ways are there. Either someone is moving the boat, or if boat is static, if river is moving at fast speed, then river current will also keep moving the boat along with itself. So here in this case, what is happening? This convection current is a kind of river. On this river, what do we have? Crust is there, contents are there. So as this convection current moves, what happens? The crust is floating over this convection current, it also start to move in the same direction. So that is how it is happening. However, gradually what will happen? This convection current, if it spends more time in the upper part, here what do we have? Temperature is lesser. That means it will become what? Cooler. If it becomes cooler, that means what it will become? Dense. Dense means heavy. After that, if it becomes heavy, where it will move? Start to sink back toward the mantle. And again, from this side also what will happen? It will sink back toward the mantle. Again, it will get heated here. Again, it will rise here. So basically what is happening? Kind of circulation, a kind of cellular circulation, cell-like circulation is happening on both sides. This is what we call as convection cell. This entire convection current, if you consider them together, this is convection cell. Convection cell 1, and this side we have convection cell number 2. So several such convection cells we can find below the Earth's surface. Clear? So Arthur Holmes now was able to explain properly, and we have evidences of this also, because at this place where this splitting is happening, gap is being created. What will happen? Molten rocks will reach above the surface from here, and this will give rise to what? What we see as volcanic eruptions. So everywhere, what we will have when two different land masses are there splitting apart, there we will have what? Volcanic eruption. So that also gave evidences or proof in support of convection theory. So what basically Arthur Holmes is trying to say, that it is not at only one place we have this kind of convection cell. Many places inside the earth, what do we have? Such convection cell exists, and due to this what happens? The land masses are moving in different direction according to the direction of the flow of convection current. Okay, and splitting is happening due to the vertical force that is being applied by the upward convection current. Horizontal convection current then moves them apart. That is how the forces responsible for content drift was given by Arthur Holmes' convection current theory. So he talked about this part. Now scientists asked him that Earth is fixed. Its like size is fixed. It is not changing, not expanding. So if suppose this crust is moving this direction, this crust is moving this direction. So at some time, what will happen? There will be other crust as well. So this crust will collide with other crust. So how this will happen? Okay. So next we try to explain the collision part. Here, what is happening? Separation. Separation is happening. Then on the other side, what will happen? Collision will happen. So he tried to explain about the collision. So let us say this is another crust, continental crust. Continental crust C is there. So what he says, that suppose this is, for example, if oceanic crust, because crust is over two types, oceanic crust and continental crust, right? So suppose this is oceanic crust. So he said that here why this collision is happening, because continental crust also is moving in the same direction. So below that, how we can draw the convection current? Convection current must be flowing like in this, and below this it is flowing like this. So here we have a collision that has happened. What he tried to say, that whenever collision happens, whichever plate or not plate, crust, plate will use later, denser crust. First point what Holmes says, that denser crust will subduct below the lighter crust. Denser crust will subduct below the lighter crust. That is his first theory. Whenever collision between crusts will happen, whichever crust is denser, that will subduct below, go below, above the lighter crust. That means in this case, from this diagram, what we can understand? This is our which kind of crust? Lighter crust. And this is our which kind of crust? This is a denser crust. And second, As per our observations, what we have seen is that we have two types of crust on the earth. One is the oceanic crust and second is continental crust. So what he says that if you compare oceanic crust and continental crust, oceanic crust is always denser and the continental crust is always light, okay, in terms of density. So oceanic crust is denser and continental crust is light. Right? Why? Because oceanic crust is made up of which rock? Basalt rock. Continental crust is made up of which rock? Granite based rock. Okay, so basalt is heavier than granite. The reason is simple. Oceanic crust is made up of basalt rock, continental crust is made up of granite rock. Oceanic crust is denser than continental crust. That means whenever oceanic crust and continental crust will collide, which crust will always go down? Oceanic crust will always go down, continental crust will remain afloat. And when this is going down here, that means here what will happen? A kind of valley-like feature will form here because subduction is happening. So a deeper part will open up. So this is what is termed as a trench. Okay, so whenever subduction of one crust below the other crust will happen, at the place where subduction is happening, which kind of landform you will expect? Formation of trench will happen. The formation of trench. What is trench? Deep valley, deep and narrow valley. In bracket you can write. Trench means deep and narrow valley is what we call as trench. A development of deep and narrow valley. Right? That is why the deepest part of the earth, where are they located? In the trench. Example, what is the deepest point of the earth today? Mariana Trench. That is example of what? Trench in the Pacific Ocean. So Pacific Oceanic crust is there, that is subducting below the Eurasian continental crust. That is why you have a formation of deep valley that is almost 11 kilometer deep from the surface of the sea. The deepest point is more deeper than the highest point because highest point is how much? 8.848 kilometers. It is Mount Everest, and deepest point is 10.8 kilometers. Right? And thus he gave this term to be here also. Here what is happening? Crust is being splitted apart. That means here what is happening? A kind of gap is being created. So if this is the oceanic crust, for example, he called this as mid-ocean ridge. Okay, so this in the same diagram you can note this one. The place where two oceanic crusts are separating apart, splitting apart. This place where what is happening? The magma is moving in the upward direction. What he call this place? Mid-ocean ridge. So here we have mid-ocean ridge and here we have trench. Only in the case of oceanic crust. Right. If the two crusts that are separating apart are oceanic crust, what do you call that place of separation? Mid-ocean ridge. If it is continental crust, what do you call it? Simple valley. Because when the land mass is separating apart, what will form there? A valley-like structure will form. So simple, we can call it valley on the continent, but mid-oceanic ridges on the ocean. So on the ocean, what you will find? Two very important features are there. One, where splitting of the oceanic crust is happening, what you will find? Mid-oceanic ridges. And where the oceanic crust is going down below the continental crust, what will find? Trench. So the largest feature, one of the largest feature or the feature that is occupying the largest area on the ocean are either ridges or trenches, right? So ridges and trenches, mid-oceanic ridge and trench. So this all what we have discussed till now since the beginning of this Arthur Holmes. This is collectively what we term as convection current theory. So if you have to write about convection current theory, what you will draw? You will draw the diagram. You'll explain properly, link the convection and this continental theory, that why Arthur Holmes gave this theory, how he was able to explain the forces that is causing the continental drift, how he explained the splitting is happening, how he explained the movement is happening, and then these 2-3 points we have discussed. The names of these zones, trench and mid-oceanic ridges, you can mention properly in the diagram, and make sure you draw this convection cell. This is the most important part of the diagram because this is what he has focused on, right? So that is the second theory, which is Arthur Holmes convection current theory, right? So basically, when Arthur Holmes is talking about this, no one has actually seen this, that there is a ridge and there is a trench. He is explaining all this how in theoretical terms. By that time, no one has been able to go inside the ocean and has been able to verify the facts of the Holmes convection current theory. It happened only after 10-15 years later. Okay, so because when something theoretically is given, what is the interest now in scientific community? To prove that or disprove that. How will you prove or disprove that? If there are indeed trenches, then his theory will be proved. If there are indeed ridges, his theory will be proved. But if suppose they go on the ocean bottom, there is nowhere such feature like ridge, there is nowhere such feature like trench. That means his theory is incorrect, right? So that is why about 12 years later, in 1952, we can say between 1952 to 1965, between 1952 to 1965, a program was launched that is called as Ocean Floor Mapping Program. Ocean Floor Mapping Program. It is basically to prove or disapprove convection current theory of Arthur Holmes. Ocean Floor Mapping Program, and this was largely led by a team of geographers whose leader was a German geographer, Harry Hess. Okay, the program was basically led by Harry Hess and his team. They were trying to understand it, whether it's like one of the objective was that, but also to understand the ocean in more detail. Okay, that was their major objective. So when this mapping program was being carried out, 5 observations were made. In total, 5 observations, main observations that were made. Okay, we'll discuss about what are these 5 observations, but what we have to understand that when you combine all these 5 observations together and explain them, talk about them, then this is what is referred as the third theory which you have to read about, that is called as sea floor spreading theory. Okay, so basically what I'm trying to say, that 5 major observations that were made during when ocean floor mapping program was being conducted by who? Harry Hess and team. All these 5 observations collectively have been clubbed together or grouped together to form the third theory, that is called as sea floor spreading theory. Okay, now this is very similar to the Holmes convection current theory, basically many parts. First part, what Holmes convection current theory has predicted, that on the ocean what you will find? Mid-oceanic ridges you will find. So this was indeed found. Mid-oceanic ridges they found. Second, what they have said, what you will else you will find? Major feature, trench you should find. This was also found. So first observation is there are mid-oceanic ridges. Second observation is there are trenches. And also the third observation what they made is that before they believe that ocean floor apart from ridge and trench, everywhere ocean floor will be kind of featureless plane, uniform plane, there are no variations. But this was found to be incorrect. The third observation what they made is there is a large scale variation in the ocean topography, bottom topography. There is a large scale variation in the ocean bottom topography. What it means, there are a lot different features are there. It is not featureless plane. Ocean bottom have lot of different types of landscapes. What are these variations? We'll discuss in oceanography chapter separately. Okay, there you have discussed about the ocean bottom topography is a separate chapter. So the detailed study of this point we'll do in the oceanography chapter. And the fourth, fifth is the most important one. The fourth and fifth part is the most important part, and that is mainly the base of this seafloor exploring theory. So two very interesting observations were made. One observation is that indeed what Arthur Holmes has said, that on one side of the ocean crust, what you will find? Mid-oceanic ridge, and on the other side, what you will find? Trench. So one side we have mid-oceanic ridge, other side we have the trench like this. So fourth observation was that if you calculate the age of the rocks, okay, age of the rocks of what? Ocean crust. So age of rocks increases from ridge to trench. What they found that everywhere on the ocean bottom, whenever they are calculating or looking at calculating the age of the rocks, it is increasing from ridge to trench. That means near ridge, what kind of rocks they have found? Youngest rock. And near the trench, what they found? They found the oldest rock. So age of rock is continuously increasing. Youngest rock near ridge and oldest rock near the trench. And more interestingly, what they found, that the oldest rock, what is the age of this oldest rock? It was around 200 million years. That means what we can write, the oldest rock on the ocean bottom, the oldest rock on the ocean bottom was only 200 million years old. Okay, the oldest rock on ocean bottom is only 200 million years old, right? But what is the age of earth? 4,500 million years, we can say. So the question came automatically that what happened to all the rocks that has formed before 200 million years, right? So this was simply explained again by the help of convection current theory. Why we have youngest rock here? Because here continuously molten rocks are coming out, and what will happen to these molten rocks? They will gradually come out, they will cool down, solidify and form a new rock layer. And again what will happen? This crust will get slightly displaced because of what? Horizontal convection current. Again a space will be created. Again what will happen? New rock layer will form. So at the ridge, what is happening? Continuously we are seeing the formation of new rocks, and older rocks are doing what? They are continuously getting displaced away from the ridge, and finally where they will reach? Near the trench. That is where what will happen. The oldest rock will be where? Near the trench, and youngest rock will always be near the ridge, and in between the rocks will be of different ages. But how to explain this? Why only up to 200 million years? So again same thing is there, because what is happening at the trench actually? Trench is going below the continental crust. That means as it goes below the continental crust, what will happen to these rocks? Temperature will increase, these rocks will melt. That means all the ocean rocks that are older than 200 million years, what has happened to these rocks? Simply we can write that they have melted, or in other words we can say destroyed. All the rocks older than 200 million years of the ocean, they melted and destroyed. Why? Due to subduction near trench. Due to subduction near. Okay, fifth point. Okay, melted or destroyed due to subduction near trench. That is why the maximum age of rock is how much? Only 200 million years. Clear? So this, then some scientists, two scientists basically, who were the part of Harry Hess team, their name is Wine and Matthias. two other scientists were there, were part of this team, called as Wine and Mathias. Wine and Mathias, they try to understand and measure the magnetic properties of this rock, or magnetism of the ocean rocks. Magnetism of the ocean rocks. So what they found out, see why ocean rock will be magnetic, because how they are forming due to the cooling of magma. Magma is coming from where? From the deep below the earth. That is where you have a lot of iron particles are there. So when these rocks start to form, the iron particles arrange themselves as per the magnetic field of the earth, right? So that is why the rocks have magnetic properties. So what he found out, actually very interestingly, you have written this, completed. So when he measured the magnetic properties of this rock, okay, suppose this is the ocean bed, okay, and here we have the ridge is there, mid-oceanic ridge. So this is here, and this side what do we have? Suppose this side we have the trench, for example. So when you measure the magnetic properties of these rocks, what is the major thing that you measure in the magnet? It is the polarity you measure. Polarity means every magnet has what? Two poles, north pole and south pole. So that is what they measure. Right. So currently, if you look at here, okay, geographically, what this is north, south, west, and east. So if you look at the magnetic field of the earth currently, the north magnetic pole of earth is where? Toward the geographical north, and south magnetic pole is where? Toward the geographical south. So the rocks that are very close to the mid-oceanic ridge, that means these are what? Youngest rocks. They also have magnetic pole in which direction? Same direction as that of the magnetic field of the earth. But after some distances, what they found, that magnetic polarity is reversed in the rock. That means south is toward geographical north and north magnetic pole is toward the geographical south. Again, what do we have? Same magnetic field. Again, what do we have? Reversed. So this kind of alternate band of the magnetic field they found in the ocean bottom. This is called as a normal magnetism, and this is what we can call as reverse magnetism or magnetic polarity. So normal, reverse, normal, reverse, normal, reverse. This kind of alternate banding in the magnetic polarity of the rock was discovered at the ocean bottom. Clear? So how we can explain this? Because these magnetic rock, like magnetism of this rock is determined by what? By the magnetic polarity of the earth. So right now magnetic polarity of the earth, and that is why all the rocks that is forming right now are having which kind of polarity? As the current magnetic polarity of the earth. But the rocks that are supposed that 50,000, 60,000 year of old rock are there, they are showing which kind of polarity? Reverse polarity. That means 50, 60,000 years back, if we have to draw the magnetic polarity of the earth, how we can draw the magnetic polarity of the earth? This side will have south magnetic pole, this side will have the north magnetic pole. That means from this observation, what we can conclude about polarity of the earth? Magnetic polarity of earth is not fixed, it keeps on reversing, right? So this point you can write down, that the earth's magnetic polarity, earth's magnetic polarity keeps undergoing reversal. Earth's magnetic polarity keeps undergoing reversal every few thousand years. Keeps undergoing reversal every few thousand years, and this reversal is recorded, and this reversal is recorded in the rocks of ocean crust. This reversal is recorded ocean crust. Okay, so this was explained by who? Vine and Matthews. Earlier 5 observation was explained by who? Largely by Harry Hess. So basically, when you combine all these observations together, Harry Hess and observation of Vine and Matthews in terms of magnetism, all this together is what we can club in the seafloor spreading theory. Diagram will be same extra diagram that this extra diagram can draw, and apart from that, all the diagram in seafloor spreading theory will be same as that we have drawn in where convection current theory. Okay. So this is the only extra diagram we have to draw. Otherwise, same diagram for convection current and sea flow spreading. Clear? So this is the third theory. Till now we have discussed about continental drift theory by Alfred Wegener, given in 1912. Then we have convection current theory given by Arthur Holmes in 1940s. And then we have the seafloor spreading theory given by Harry Hess, Wine and Matthews together in between 1950s to 1960s. Right? That is the time duration. But still, even if you combine all these theories, many questions were not explained by this theory. For example, how do mountains form? That is not properly explained by theory. Why do we have volcanic eruption that happens everywhere? Like a lot of places are there, we are having what? Volcanic eruption, right? Why do we have earthquake that happens at many places on the earth? These were still not fully explained by any of these theories. And thus, more work was done in the coming decade. And by the early 1970s, a new theory came into existence, which is the most revolutionary theory, most advanced theory that explained almost everything about the earth. This is what we term as plate tectonics theory. So the last theory which we have to talk about is spreading theory. So in 1970s, we have a new theory that was given called as plate tectonics theory, largely by three geographers. One was obviously from the last, you have Harry Hess was involved here. Second, you have is J.T. Wilson, and third is Morgan. Three main scientists or geographers who are associated with plate tectonics theory: Harry Hess, J.T. Wilson, and Morgan. J.T. Wilson, here, if you want one point you can remember is this term, the term plate. He was the one who first time coined the term, okay, or actually gave the term plate. So the plate term was given by J.T. Wilson. Before understanding theory, what we have to understand? We have to understand about the term itself. What does plate means in this theory? Because till now, what we are talking about? Using the term continental crust or oceanic crust. So basically, what is crust? Yesterday we have discussed that we have three layers: crust layer, mantle layer, and core layer. So before this theory, scientists believe that crust is moving over the mantle layer, right? Entire crust is there, it is solid, it is moving over the mantle. But that underwent change when more development in the technology was made and more better understanding of the layers of earth was made, and then it was found that yes, the entire crust is here, that is in solid state. But apart from that, a small part of mantle that is just below this crust, this is also in which state? Solid state. So we have solid mantle, or what we can term it as upper solid mantle, because it is upper. So we have crust, entire crust, and then upper solid mantle. This behaves like how? Like a single layer. Okay. entire crust and the upper solid mantle. It behaves like a single layer. And this single layer, why it behaves like a single layer? Because this entire layer moves together. And the part of mantle over this layer is moving was given the name of asthenosphere. That means the entire crust and upper solid part of mantle is behaving like how? Like a single layer, and it is moving over the lower part, which is termed as asthenosphere. And the entire single layer is called as lithosphere.
The asthenosphere is only the upper solid mantle.
Asthenosphere is below the upper solid mantle. It is kind of semi-molten layer, not fully molten, not fully liquid, solid. Asthenosphere is kind of semi-molten in state. And entire lithosphere is moving over asthenosphere. Right? So what do we have? Crust and upper solid mantle. Together, what do we call this layer? Lithosphere. And lithosphere is moving over the semi-molten layer, which we call as asthenosphere. Now, lithosphere is entire Earth is not made up of, like entire Earth is what? Lithosphere, but it is not a single, what we can say, it is not a single this structure. Lithosphere is actually broken apart into different parts, different fragments, and each of these individual fragment is what we call as plate. Okay, that means what is the plate? Plate is individual broken fragment of lithosphere. Right, like this. A plate is individual broken fragment of lithosphere. Individual broken fragment of lithosphere. Clear? So overall, lithosphere is broken into different fragments. Each of these fragment is what we call as plate. So if you look at the world map, overall 7 major plates are there that we can identify. So 7 major plates, 5 are continental plate and 2 are oceanic plate. We can write like this. Total 7 major plates are there. In this, 5 plates are continental plates and 2 plates are oceanic plate. Names you can write the 5 continental plates. What are the 5 major continental plates? African plate, Antarctic plate, North American plate, South American plate, Eurasian plate, right? How many are there? 5. So these 5 are the major continental plate. Okay, there are other plates are also there, but these are minor ones because small. So look at the atlas actually. Okay, I'll suggest in atlas you have the plates. The names of the plates are given. Minor plates, important minor plates are also given. So that is your homework. Look at them and write down the names of the minor plates as well. Okay, in atlas it is given. And what are 2 major oceanic plate? Pacific plate and Australian plate. We have 2 major oceanic plate. First is Pacific plate. Second is Australian plate. Okay, this is very important, last one, because Australia is what? Australia is a continent. But if we talk about Australian plate, it is which kind of plate? It is not a continental plate, it is an oceanic plate. Australian plate and Pacific plate. right? So total how many plates? 7 major plates. And in between all these major plates, what do we have? Small plates are there. Like for example, Indian plate, it is a small or minor plate. Arabian plate, that is a minor plate. So Philippines plate is there, that is a minor plate. So a lot of minor plates you will find on the atlas. Write down their names. And in exam, what can be asked? Match the following question can be asked. Names of the minor plates can be given, and where these minor plates are situated, between which two major plates. That is what can be asked. Okay, so that is why location you can write down from the atlas. The name of minor plates, and this minor plate is situated between which of the major plates, right? That is the plates. So understand what is a plate, what are the different types of plate, oceanic plate and continental plate. Now what we know, that due to convection current that is flowing inside the earth, these plates are not static, they keep on moving on the earth. So if the plates are moving, at some point what will happen, they will interact with each other, right? If you compare any two plates, what will happen, either plates will be coming toward each other or they will moving away from each other. So any kind of movement is what we call as interaction. So next you can write plate interaction. Next point what you have to study about is plate interaction. Plate interaction. So on the earth surface, three types of interactions are observed. We have convergence, we have divergence, and we have transform plate interaction. Plate interactions can be classified into three types: convergence, divergence, and transform plate interaction. So what is convergence? You can write down when two plates are moving toward each other. When two plates are moving toward each other, that is called as convergence plate interaction. And the boundary where convergence happens, that boundary is called as destructive boundary. Okay, so another term you can write, the boundary where convergence happens, the boundary is called as destructive boundary. What is the other one? Divergence. What is divergence? Opposite to convergence. So in convergence, what is happening? Two plates are moving toward each other. In divergence, what will happen? Two plates will moving away from each other. So you can write when two plates move away from each other. Diagram you can draw, simply arrow will be different. So when two plates move away from each other, we call it as a divergence. When two plates move away from each other, that is divergence. And the boundary is called as constructive boundary. The boundary is termed as, called as constructive boundary. Right?